Please start out by answering the question on our summary slide. What did we learn in our previous lesson? Our learning target today says, I can solve a quadratic equation by graphing. And our EQ says, how do you solve a quadratic by graphing? Well, if you graph a quadratic, the solutions are the x-intercepts. So our vocab word says roots. The roots are the x-intercepts of the graph. They are also sometimes called zeros or solutions. So all of these words mean the same thing. Roots, x-intercepts, zeros, or solutions. So when you look at the graph, each of these graphs, the first one has two x-intercepts, so it has two roots. The second one only has one because the vertex sits on the axis. And then the last one doesn't have any roots. It doesn't cross the x-axis. So you can still graph it, but the solutions or the zeros, there wouldn't be any for this one. So our quadratics can have two solutions, one solution, or no solution. Then you solved quadratic equations by factoring. So we already did that in Chapter 8. We solved by factoring. You can still do that sometimes. Now we're going to solve quadratics by graphing, and we're going to estimate solutions of quadratics by graphing. So if we can't find the exact solutions, it's okay if we estimate them. Why? Dorton Arena at the State Fairgrounds in Raleigh, North Carolina has a shape created by two intersecting parabolas. The shape of one of the parabolas can be modeled by this equation, where x is the width of the parabola in feet and y is the length of the parabola in feet. The x-intercepts of the graph of this function can be used to find the distance between the points where the parabola meets the ground. All right, here we go. We're going to solve by graphing. So this is going to be a good review of graphing. So we're going to find all of these things and then add it at the bottom. We have the roots. So we start with the axis of symmetry. So first of all, we need to know what A, B, and C are. So remember, A is 1, B is -2, and C is -8 for this quadratic. The formula for the axis of symmetry is x equals the opposite of B divided by 2 times A. So if B is -2, the opposite would be +2, and then 2 times A, so 2 times 1. So I have 2 divided by 2, so x equals 1. 2 divided by 2 is 1. Remember that the axis of symmetry is a line, so you need to write it as an equation of a line. So that's why I start with the x equals. So x equals 1. Okay, now I'm going to draw my line. Axis of symmetry, x equals 1, so it's a dashed line through x equals 1. So that's my AOS. The next thing we find is our vertex. Remember that the vertex point sits on the AOS. So the x-coordinate of your vertex we've already found, it's 1. Now we just need to plug in 1 in our equation. So this is what our equation looked like at the beginning. So now we know that x is 1. So we turn both of the x's into 1's. 1 squared is 1. Minus 2 times 1, which is 2. So 1 minus 2 is -1. Minus 8 is -9. So that's the y-coordinate of our vertex. So 1, -9 is way down here. So that's my vertex point. The next thing we need is our y-intercept. Our y-intercept is just the c value, so it's -8. So if I graph -8, and then reflect it to the other side, I get my quadratic. Okay, so now I need my domain and range. Remember, the domain is all of the possible values for x, so that's anything. We could plug in anything we want for x and we can solve this equation. Then the range, the y values, this vertex is the lowest point on the graph. It's a minimum. So that means that the y value of -9 is the lowest point it hits. So y is greater than or equal to -9. For all of the other points on your graph, they're higher than -9. Okay, so now we need our roots. So looking at my graph, where does it look like it crosses? Maybe I need to kind of fix this side of my graph. So looking at my graph, my estimates are here and here. So that would be what points? -2, this one's -2, and then this one is +3. So those are my estimates, -2 and 3. So we're estimating where it crosses through the x-axis. All right, next one. Solve by graphing. And notice this one says set the equation equal to 0 first. So remember, your equation has to be in the correct order. It has to be in standard form first. So I need to move this one over. So I need to add 9 on both sides to cancel out that -9 and get it to be a 0. So now we've got, I can put my 1 in front, we've got our A, B, and C. Okay, so axis of symmetry, x equals the opposite of B. So the opposite of -6 is +6, and then 2 times A, which is 1. So 6 divided by 2, so that is 3. So our axis of symmetry is x equals 3. So draw that on your graph. Then for the vertex, we've got the first coordinate. Now it's 3. Next, I need my equation. So x squared minus 6x plus 9 equals 0. So that's just the same as saying y equals. So when you set your equation equal to 0, there, means the same thing. So plug in my 3's. 3 squared minus 6 times 3 plus 9. So 3 squared is 9. 6 times 3 is 18. So 9 minus 18 is -9 plus 9. So that's 0. So 3, 0. So my vertex is right here. 3, 0. Now my y-intercept. Remember, once it's in standard form, the y-intercept is just c. So my y-intercept is 9. So way up here, then I reflect it to the other side. So it's 3 away from the axis of symmetry. So I have to go 3 on the other side and then draw my graph like that. My domain is all real numbers every time. And my vertex is the lowest point again, so it's a minimum. So the y values, this y value is 0, and that's the lowest point. So it's greater than or equal to 0. And the roots this time, take a look at where that vertex is. It is on the x-axis at 3. So this one only has one root, one solution, and it's 3. All right, next one. Axis of symmetry. So x equals the opposite of b, so -2, divided by 2 times a, and a is 1. Negative 2 divided by 2, negative 1. So x equals negative 1. Draw that on my graph. And that's the first half of my vertex, negative 1. So y equals x squared plus 2x minus 4. Plug in negative 1 for your x's. Negative 1 squared is 1. 2 times negative 1 is negative 2. So 1 minus 2 is negative 1, minus 4 is negative 5. So negative 1, negative 5 is my vertex. My y-intercept is negative 4. So negative 4 is right here. If I zoom in, negative 4, and then reflect it to the other side, and draw your graph. And remember, we're estimating these intercepts. We're estimating them. Our domain is all real numbers again. Our vertex is a minimum. So the range y is greater than or equal to that y coordinate on my vertex, negative 5. Now these roots, my estimates look like 2, positive 2, and negative 3. Positive 2 and negative 3. So it looks like 2 solutions. If you wanted to graph those on Desmos, you would be able to check and see if your estimates were close. I'm not too worried about it today though. All right, so remember, if you draw your graph, all of ours had roots. So we had 2, we had 1, we had 2. So if you draw your graph and it doesn't cross the x-axis at all, remember that means that there aren't any. There aren't any. So this third situation, we didn't have an example like that, but that is possible. When you draw your graph, it is entirely possible that it might be completely above the x-axis, or it might be down here where it's completely below, going down. Okay? That's all for our lesson today.